Okay, you should be able to see my screen. So the first question was for Alireza. In US commercial buildings, they do operate the building at overpressure at 12.5 Pascal. So in this case, the ventilation rate cannot be reduced as it's been taken into account.
Here, you hear me now?
Yeah, that's much better.
Yes. Actually, what I want to answer to this question, that's a very excellent question, and we have to focus on that in the future also. But as a solution, if you improving building air tightness, it means that enhancing the envelopes air tightness can reduce the amount of the outdoor air needed for these pressure differences. So the first step is the air tightness of the building. It has to be careful to have it. And the second is that if you have a demand control ventilation system, so you can actually adjusting ventilation rate dynamically to ensure that pressurization needs are met actually. And in addition to this one, I will say that when you have a recirculated air and air cleaning, so actually the amount of the air decrease. So it can also help that you can reduce the energy consumption and while maintaining indoor quality. So the first is air tightness. The second is if you can use demand control ventilation and recirculation in the system. I hope I answered the question.
Okay, I think so. Thank you very much, Alireza, for that. Do not forget that you can use the Q&A box to continue asking questions during this Q&A session. We'll add them after those already there. So the second question was for Sasan, and it refers to what do you include in air change per hour? Is it infiltration rate or does it include every air change in the building?
No, it's all the building. We consider the building as one zone. So there are not different zones in the building. So air change rates per hour is including in all the building without infiltration.
Oh, without infiltration. So that's the air renewal of the full building.
Yeah.
And it's not only, because sometimes we call ACH only the infiltration rate. So I guess that was the question. Thank you. So the next question is for Bjarne. Is the acoustic performance of air purifiers taken into account? It's another way of energy consumption related to the comfort of occupants.
Well, we have not dealt with any issues related to acoustic performance. But of course, if an air purifier is very noisy, people will not use it. It's the same if you have a ventilation system and it's very noisy, people shut it off. So the acoustic is very important. So we have just assumed that there's no disturbing noise, so people are going to use the air purifiers. So the acoustic doesn't change anything with the KPI we have established, but I agree it's an important parameter, and we have often seen both for ventilation system and for air cleaners, they are not used because of acoustic. But of course you can do with air cleaners, and so you can use them before the occupants get into the space. Then the noise level doesn't mean so much.
Okay, have you set a limit in decibel of the one you've tested?
No, we don't set a limit, but there's other standards which are dealing with acoustic. We are working on an ISO 17772, and we are working on a similar CEN 16798 Part 1, where there will be some acoustic requirements to what is acceptable.
Good, thank you. And the other question we have is addressed to all speakers. So, what are your thoughts on the use of electrostatic precipitators filters, that require energy consumption?
I can, Bjarne speaking, I can say some. In how to evaluate if they provide any clean air, and we use this KPI, clean air efficiency, the energy use consumption of the device is taken into account. But electrostatic filters mainly are working on the particles you have in the space. But there are other substances and also human bioeffluents, so may not be removed that efficiently with electrostatic filter. We also have to be careful that you have to check if there's generated any ozone, because if you have ozone is very reactive and will react when it comes into the space with human bioeffluent, and we see new substances will be generated which people find very annoying. That's why we have seen that some air cleaners make the air worse than without the air cleaner. So in the testing method that we are proposing is the 2 stages. So first you test if the air cleaner at all have a positive or negative effect on the perceived air quality. If it's negative, you don't do the second test to find the clean air delivery rate. Only if it's not negative, then you can do additional test. I don't know, if, Ali, if you have other...
Yes, I mean, exactly what you say, that's totally correct. And I know that this kind of air cleaner is efficient for particles. But you have to remember, for the all air cleaners, when you connect it to power, if it is our 5 kilovolt, so it make generation of ozone to the room, and many of these people that call and claim that they have a problem with health and so on. Even if you have a less than 5 kilovolt, so do you generate, but it is so small amount of the ozone, so you cannot maybe measure it. But remember that when you have an ozone and you have some kind of cleaning that has, for example, limonin or something like that, so generate a lot of particles in the room. So we have done this study, and we use this kind of air cleaner in a room without ventilation and waited 24 hours in order to see what happened. And we use limonin and also ozone together in the room. The result was accumulated a lot of ultrafine particles in the room. So it is very important to be careful that the device that you use in order to clean the air doesn't generate even a small amount of the ozone to the room. Yes, I hope it is an answer to the question.
Yeah, and let's remind that your study was focused on perceived indoor quality and not on the other aspects such as health. So that's why particulate matter, it was less of interest for you, right?
Yes.
I don't think we have any other questions. Oh yes, one's just coming. See, how can we compare the energy performance if we need to consider more than one pollutant?
Well, you have noticed when the way we establish the clean air delivery rate, we are using the total exposure of people, both from building sources, emission from building materials, and also emission from people. So this is taken into account. You can also find it, and there's a test method for that also, if you only look at one particular pollutant, which you sometimes do if you want to simulate the VOCs. You may use formaldehyde, and you can do a testing with that. Also, you don't use perceived air quality, but you basically use the concentration before and after an air cleaner. And there you can come up with a clean air delivery rate. But that's only for that pollutant, and it's not something where you can directly compare with the general requirements to ventilation. But it will be helpful for this one pollutant.
Okay. Thank you very much. I don't think we have any other questions now, so I think unless you want to discuss something else, it is time to close this webinar.
No, I just want to say this energy and air cleaner, as you can see from the presentation from Alireza, that it will continue. So we hope it will probably be decided here in the spring that we will continue with a new annex, so we get a deeper insights and hopefully get some more field data, not only simulation, regarding air cleaner and the effect on the indoor environment, the equivalent energy use.
Yes, thank you, Bjarne.